Greetings, young mathematicians. Welcome to Saxon Math, Lesson 95, Volume of a Right Solid. So we're going to start out with our mental math, which you've already done. And let's take a look. So positives, negatives. Well, essentially we are taking a positive 72 and adding negative 100, which is going to send us left on the number line. So essentially we just subtract these two. To get 28, and we can think of it as we count up the number of negative signs in our equation. There is 1. That is an odd number, and so that means that we have a negative number for our answer, negative 28. Order of operations, exponents. Well, starting out with 2 5/10 times 2 5/10. Okay, and then looking here, and we've got 2 digits behind a decimal point. So boinky, boinky, 1, 2. Gets us to 6 25/100 times 10 to the power of, since we're multiplying similar exponents, just 6 plus 6 equals 12. Gets us 6 25/100 times 10 to the power of 12. Ratios. So doing this out, so of course we do some cross multiplying goodness. 100y equals some quick mentally math. I can say 1 times 60 is 60, then add half of that to get 90. And so now we can just divide each side by 100. Getting us y equals 9/10. Measurement. Convert 25 degrees Celsius to Fahrenheit. So remember, multiply by 1.8 and then add 32. So doing that quickly. Quickly. Can save 48, 200. 250. That will get us 55. Oh, excuse me. 45 plus 32. Forgive all my chicken scratchings here. Will get us 77 degrees Fahrenheit. Oh, let me get that all off the screen. 77 degrees Fahrenheit. Calculation. Well, I can look at 8 times 2 is 16. Then plus, I know 3/4 of 8 is 6, gets us 22. right, 50% more than 60. We just did that up here. Essentially, half of 60 is 30, so 30 plus 60 is 90. Oh boy, I love these. Okay, so there are 6 pairs of black socks, 3 pairs of white socks, 2 pairs of brown socks. So we have a total of 11 socks. What is the probability of selecting a pair of white socks? Is 3 in 11. And calculation percent. 10% of 300 is how much more than 20% of 100? Subtracting these, the answer is 10 more. All right, so moving along to our lesson of the day. It's very interesting and fun, but starts out with a bit of a mouthful here, so I'm just going to throw this up on the screen. So we're talking about a right solid is a geometric solid whose sides are perpendicular to the base. So the volume of a right solid equals the area of the base, and actually I can accidentally move this around a bit, but we can use the top, speaking about our base. So the top, the base, multiplied by the height will get you the volume. And that's just essentially what we've been doing is we multiply the length by the width as our first step anyway, and then we multiply that by the height, and in this case it's about the same thing. So we can look at this and see that it is 5 across, and we are working in meters. Times the 2 meters. So that's going to get us to 10 meters squared. And then we multiply that by the height, which is 3 meters. And so we are multiplying our unit multipliers. So essentially, to the power of 2 plus to the power of 1 is to the power of 3, or cubed. And we multiply these two guys, getting us 30 meters squared for the entire volume. So when we're looking at our different shapes, we can see how we should get the volume of each of these prisms. So with the right square prism, that's pretty basic because we're essentially getting the area of the base and just multiplying that by the height, which is essentially what we've been doing the whole time. for these things. We're just assuming a first step. Then for the right triangular prism, what we'll do is compute the area of the triangular base and multiply that by the height. And then for a right circular cylinder, which essentially means that the sides are perpendicular, say, to the points of the diameter. And so what we do for that is we will compute the area of the circular base and multiply that by the height. Okay, so example 1, find the volume of the right triangular prism below. Dimensions are in centimeters. We show two different views of the prism. So in this case, while technically we're looking at this from the side, we are thinking of this as the triangle as the base. So for doing that, start out with, and we're doing this in centimeters, so 3 times 3 centimeters times 4 centimeters. That's our side here. And since this is a triangle, we're not looking at this whole kind of square there. So we are going to divide the result by 2, giving us 12 centimeters squared, because we multiply our units, divided by 2, equals 6 centimeters squared, and then take our 6 centimeters squared and multiply that by the length here, times 6 centimeters. So that gets us 36, and then we're going to add this unit and this unit, well, multiply them, which is essentially adding the exponents. And we can think there's an imaginary one there. So 36 centimeters to the third power, 36 centimeters cubed. All right, the diameter of this right circular cylinder is 20 centimeters. All right, let's label this guy. Is 20 centimeters. Its height is 25 centimeters. What is its volume? Leave pi as pi. So, well, that means we don't have to actually do any computation. I suppose that they have these examples such as they are to have us practice just leaving functions as functions in problems. And, well, saves us a few steps. So remember that in order to get our base here, wall diameter is 20 centimeters. We're not looking for the diameter, we're looking for the radius. It's 10 centimeters. So essentially it's 10 centimeters times pi. Squared. So that will get us 100 pi centimeters squared. Okay, and then we just want to multiply that by our 25 centimeters for the height, getting us 2,500 pi times pi centimeters cubed for our answer. Example 3. Eric stores gardening tools in a shed with the dimensions shown. Find the approximate volume of the shed. All right, well, this is going to be a couple steps here. First thing we've got is our roof to figure out, which is a triangular prism. So we're going to figure out what our triangle here is. So we've got our height, so our 2 feet. And we are going to multiply that by the width and along the length, which means I probably did not give myself enough space up here. I'll bring this down here. We got our 2 feet times 8 feet because we're using this up here times, oh hey, what do we do with this? 10 feet 2 inches. Well, luckily we have the operative word. Find the approximate volume. So you know what? I'm going to take that 2 inches and I'm going to make it into a butterfly. A nice blue butterfly, and we'll never think about the 2 inches again. So times 10 feet. But remember, since we're figuring out the triangle, we are going to need to divide the entire result by 2. So going across, 2 times 8 is 16. 16 times 10 is 160. I know that dividing 16 by 2 is 8. We're just talking about 10 times that much, so we're talking 80. And we're multiplying, we're kind of adding our feet multipliers together. So 1, 2, 3. 80 feet squared for the volume of our roof. All right, let's get all that off the screen. I'm keeping my 80 feet though. Oh no, my butterfly. Let's put that back. Okay, so now let's figure out the rectangular prism here. So pretty simple. We can just look at this as 8 feet times 7 feet times 10 feet. So 8 times 7 is 56 times 10 is 560 cubic feet. So we can add those. Oops. And that should be cubed. Excuse me. Okay, and so we are just adding our bottom part of the shed to the roof of the shed. Getting us 640 cubic feet. All right, so, well, you had kind of a simple practice set for the last lesson. I guess we get to make up for a little bit of that with looking at this, but I don't think any of this was really that tricky. So let's have the practice set done for the afternoon, and you have a fantastic day. I'll see you at the 10:30 meeting.